So a couple more examples that we should go through for the same extreme value property, right? So let's consider a function that maps the open interval from 0 to 1 to all reals, right? And what's the function over here? The function is simply fx equals x, right? And this is valid for all x that are belonging to 0 as well as 1. Now the weird thing over here is that we're considering the open interval, right? So if we're considering that, x simply lies between 0 and 1, which means x is not equal to 0 or x is not equal to 1. So that kind of changes the question a little bit, right? So what you need to consider at this point is that this function may be continuous in this particular domain mentioned, and we can check that too, right? If that's a 0, let's just change that a little and make it better, and that's 1, then the y equals x line is simply going to be 1 1 and 0 0. So that's the y equals x line from 0 to 1, and that's the coordinate 1 comma 1. So basically it does not include 0 and it does not include 1, right? But all the values in the middle are continuous, right? It's giving me a continuous function in the middle, so it's continuous. So the first condition is satisfied, so it's continuous for all values of x in the particular range. What's the second thing? If this is true, then what about 0? 0 is not being satisfied, neither is 1, which means that we're going to get closer and closer to 0 from one end and closer to 1 from the other end, right? And we can keep on doing this, but you guys do get the point, don't you? That's 0.999 all the way up to 1, but it's never equal to 1 and it's never equal to 0, which means what? Which means there is no minimum or there is no maximum in this particular set, because 0 and 1 are not included. If they were included, it would be a different story, because then we could say that 0 and 1 are. Now we can't, right? So let's just consider that. So there would be no minimum or maximum in this particular set. Okay, that's just something you guys need to remember. Let's do another example that can help us understand what's going on. So what if you have a constant function? We do remember what a constant function is, right? It's y equals c, or simply f of x equals c, right? And it maps all the real numbers to a particular constant, right? But that is a real as well, if you think about it. So if that's a real, how many times do you think is a maximum or a minimum value attained? So we could define a domain. Let's do that. Let's define 0 or 10. Plot the graph y equals c, right? For that, y equals c would look something like this from 0 to 10. Right? How many times do you think a minimum and a maximum is being attained over here? Well, let's first use the extreme value property. The extreme value property suggests that if this is continuous for every value that ranges from 0 to 10, then it attains a minimum and a maximum value at least once. Well, as it turns out, it attains a maximum and minimum value infinity times, or times that you can't count, because since we're considering real numbers and the values from 0 to 10 are uncountable, right? And if that's the case, then this is a problem, because at every particular point the value of c is resulting, and there's just one constant value that's keeping, like, that will keep on repeating, right? It's going to be c for 0, for 0.00, all the way up to 1 maybe. This could be c, and c would keep on repeating, so the same value is being repeated multiple times. So the minimum in this case is equal to the maximum. It's the same thing, same condition being satisfied, right? So that's something you can consider. That's a different perspective to think about it. Some people might think that there's no minimum and no maximum. That's fine too. It really depends on the argument you guys use. So that's pretty much it for the extreme value theorem. In the next video or section, we're going to be talking about the intermediate value theorem, which is another important theorem that you guys need to use.